So we're going to look at what the trend in the reducing power is of the halides now. Now, the term reducing power is the ability to give or force electrons onto another atom, in this case sulfur. Now, if we look at the sulfur in sulfuric acid to start with, it's a +6 oxidation state. Now, when we react sulfuric acid with a chloride, we don't see any change in the oxidation state of sulfur. So therefore, there are zero reduction products, so no electrons have been lost from the chloride. However, with bromide, we see SO2 is produced. Now, if we look at the oxidation state of sulfur in this, we see that it's +4. So it goes from +6 to +4, so it has gained 2 electrons, and those electrons come from the bromide. Now, bromide is a better reducing agent than chlorine. However, if we look at iodide, being a considerably bigger molecule, a bigger atom, we can produce SO2, S, and H2S. And if we look at the oxidation states of each, this is +4, this is 0, and this one is -2. Let's write it over the top of it, -2. So what that means is that the sulfur in sulfuric acid starts as +6. It then gains 2 electrons from the iodide to produce a +4 oxidation state. It then gains a further 4 electrons, so a total of 6 electrons from the iodide, to produce sulfur of 0 oxidation state. And then the iodide even more gives a further 2 electrons to form H2S. So iodide is excellent at giving up its electrons. Another way of saying that is it's a very good reducing agent. Much better than bromine, which is much better than chlorine. So in terms of reducing power, it goes in this order. Now, the reason for it is because it's easier to lose electrons from a larger radius because there's more shielding and therefore a weaker overall electrostatic force of attraction holding these electrons to the nucleus.